Hello students, I am explaining chapter number 1, Matter in our surrounding from class 9 science. And in this video, I am going to explain the activity that is 1.12, which is under effect of change of temperature. So starting part of this activity we have seen in the earlier video, which is already uploaded, and now we are going to see the continuation of this activity. So we'll start with the continuation of activity 1.12. When we heat water, its particle starts moving faster. So before going to this continuation, let me explain what we have seen in the earlier video, that is earlier part of this activity. We have seen the conversion of ice to water, and then we have seen the conversion of water to vapors. So this part 1 and part 2 we have finished in the earlier video. Now I am going to continue with this topic, that is conversion of water to vapor. Now see, when we heat ice, the particle will gain the energy, they will overcome the forces present in the particle, and it will convert into liquid state, that is water. When we continue heating water again, whatever force of attraction is present between the particles of this water, that also will overcome and water will get converted into vapor state. So let's see, when we heat water, its particles start moving faster. So see, in ice, all the particles were closely arranged. The movement of particle was very less, and therefore ice was solid. When we heated this ice, the whatever heat energy is supplied, that energy is gained by these all the particles, and they overcome the forces present between the particle and they separated. So the ice converted into liquid. So see here, liquid have little bit of space between the particles and they can vibrate, they can move. Now, but in this water also, the particles of water, still there is a force of attraction. That's why these particles are close to each other. When we heat it again, if you continue heating this water, again this particle will gain more energy. They overcome the forces still they have between each other and they separate, they move far from each other. For example, this is the state. Now they will look like this. Particle will be far away from each other, and this state is called as vapor state. So when we heat water, particles start moving faster because the space between the particle has been increased. As the temperature increases, the particle gain more energy. At certain temperature, they get enough energy to overcome the force of attraction. So water is started boiling, and at certain temperature, they gain more energy, and whatever force present in between the particle, these all forces will overcome, and they start changing into gaseous state. This temperature is called as boiling point of liquid. So the temperature at which all the particles present in the liquid overcome the force of attraction and started converting into gaseous state, that temperature is called as boiling point. Boiling is a bulk phenomena. Bulk means together, group of particles. So if you want to see boiling phenomena, we cannot see this phenomena with a single particle. If you want to see boiling, there should be more number of particles. All should move here and there because of gaining energy. Then only we can say the substance is boiling. With single particle in a beaker, if you keep a single particle in a beaker, you cannot see that it is boiling. There should be many number of particles. When you heat, all the particles will move faster, and that is called as boiling. Therefore, it is called as boiling is a bulk phenomena, which means the change happens throughout the liquid, not just at the surface. So whatever change is happening due to boiling or due to heating the water, that change is happening throughout the liquid and not only on the surface or any single area. For water, the boiling point is 373 Kelvin or 100 degrees Celsius. So when the temperature reaches 100 degrees Celsius in the thermometer, water starts boiling. Water get converted into gaseous state. This is in terms of degree Celsius. When you want to convert it into Kelvin, what you have to do, 100 temperature you take as it is, and you have to add 273 Kelvin. So 100 plus 273 will be 373 Kelvin. So this is called the temperature in terms of Kelvin. So remember, 373 Kelvin or 100 degrees Celsius, both are same. This is in degree Celsius, this is in Kelvin. So if you want to convert degree Celsius into Kelvin, you have to add 273 Kelvin in your degree Celsius value. So that's why The boiling point of water is, in terms of degree Celsius, it is 100 degrees Celsius. In terms of Kelvin, it is 373 Kelvin. You have to remember this. Then, what is latent heat of vaporization? It is the heat energy required to change liquid into gas at its boiling point without any change in the temperature. So when we started heating the water, after reaching to 100 degrees Celsius, water started converting into gaseous state. Water started converting into gaseous state. And when this conversion is happening, the temperature in the thermometer remains same, remains constant. It will not at all change. When all the particles of water get converted into gases, then again the temperature will start increasing. So during boiling, whatever heat we are supplying, that all heat is used by this particle to convert, to change the state from liquid to gases. And that heat is called as latent heat of vaporization. As we have seen in the earlier video, latent is nothing but hidden. So whatever heat we are supplying during boiling process, that all heat will be hidden inside. It is used to change the state from liquid to gas. Liquid to gas. So that will not increase the temperature in the thermometer. Therefore, it is called as latent heat of vaporization. Why it is vaporization? We are converting liquid to gas. So it is called as vaporization. So next, particle in steam. Steam is nothing but water vapors at 100 degrees Celsius or 373 Kelvin. So particles in steam have more energy than particles in water at the same temperature. Very simple. When we convert liquid into gaseous, during the conversion, it takes one hidden amount of energy. That is what is latent heat. So the gas particle will have more energy because they have that latent heat compared to liquid particles. And we have already know liquid particles will have more energy compared to solid particles because these particles will also have latent heat of fusion. So that's why the sentence is, I'm reading once again, particle in steam. Steam is nothing but water vapor. So particle in steam have more energy than the particle in water at same temperature. This is because they absorb extra energy called latent heat of vaporization to change into gases. So this can be shown. So see here, it is from your NCERT book. Solid state, when it is heated, it converts into liquid state. Liquid state, if you continue heating, it converts into gaseous state. So this is called as conversion of states, that is solid state to liquid state to gaseous state. And remember, whenever you want to convert solid to liquid, you have to heat, because whatever forces of attraction is present between the particles of solid, to overcome those forces, we have to give the energy, that is heat. When it converted into liquid state, still this particle will have force of attraction between them. And to overcome this, again you have to continue heating. So when we continue heating, these all particles will gain the energy, they overcome the forces and they convert it into gaseous state. And here the particle will be far away from each other. The forces of attraction will be very, very less. The same process can be reversed. We can decrease the temperature, we can cool it and convert gaseous state to liquid state. So when we cool it, when we decrease the temperature, these all the particles which are far away from each other, these all particles will come close and get converted into liquid state like this. If you still cool it, if you still decrease the temperature, again these all the particles will again lose the energy and convert into solid and they will come very, very close to each other. So here we can say, if you take steam and if you cool it, steam will get converted into water, that is liquid state. If you again cool it, then the water will get converted into solid. Solid is nothing but what? Let me write it ice here. So I'll write here ice. So we can convert ice to water, water to vapors. And also we can reverse it back, vapors to water, water to ice. So this is the conversion diagram for matter. So I hope you have understood this process, what I have told. Now we'll see the next activity. So now we are going to move the next. We know that most substances change from solid to liquid and liquid to gases when it is heated. We have already studied this. When we heat solid, solid converted into liquid. When we heat liquid, liquid will convert into gases. And this is due to by absorbing or by gaining the energy when we are heating. But some substances changes directly from solid to gas without becoming liquid. So there are some substances, when you heat it, they will directly convert from solid to gas. They will not convert into liquid state. So see here, when we heat solid, actually we know solid will get converted into liquid and liquid will convert into gases. But There are some few substances which when you heat, solid will directly become gaseous state. This process is called as sublimation. Remember this word. The process where when we heat, solid directly convert into gases without undergoing liquid state is called as sublimation. Similarly, gas can change directly into solid without becoming liquid. So when you cool this gas, when you heat it, solid will directly convert into gas, and when you cool it, gas will directly convert into solid. There is no liquid state in between, and such process is called as sublimation. This sublimation we will study with the help of activity 1.13. So let's see the activity. The aim of the activity is to show that camphor undergoes sublimation. Camphor is the common substance which we use daily in our homes during puja. So here, when we heat camphor, it undergoes the process called sublimation. It directly changes from solid to gas. So let's see it. Apparatus require china dish, camphor, inverted funnel, cotton plug, burner, or a heat source. Any heat source you can use because we have to heat it. So the procedure, here you can see the diagram. This is the diagram from NCERT book itself. So here this is called burner, china dish, camphor, inverted funnel, cotton plug, and these are camphor vapors. Let's see the procedure. Crush some camphor and place it on a china dish. So we are going to take this china dish, and on this china dish we are going to keep some of the camphor by crushing into small pieces. Cover the china dish with the inverted funnel. So we know the funnel, the glass funnel will look like this. We have to use glass funnel here. So glass funnel will look like this. This funnel we have to invert it and we have to keep it on a china dish. It will look like this. Put cotton plug in the stem when of the funnel. Sorry, put cotton plug in the stem of the funnel. So this is the stem, and on this stem we are going to put here cotton plug. Why we are keeping this cotton plug? Because when we heat, whatever gas we are going to get, that gases should not go off. If they go out, then the camphor will be reduced. It will go off, and the gases will go into the atmosphere. So that's why you keep your cotton plug. Heat the china dish slowly. Now this whole apparatus we have to keep it on a burner and heat it slowly. Observe what happens to the camphor. So when you heat it, this solid camphor we can see it will gain the heat which we are supplying, and this solid will directly becomes gases. The camphor will convert into gases or the vapors. So see the observation. Actually it is result. So what is the observation? Camphor changes directly into vapors. There is no liquid state. You maybe have seen when you take camphor for the god puja in your home, and when you heat it, it directly becomes converted into gases or the vapors, which you can see the black color vapors will be coming out from the camphor. So solid directly converted into vapor and then deposits as solid onto the funnel. So here what happens when you heat this, the camphor which is present here, it becomes gases or vapors, it comes up. Once this vapors comes up and when they touch to this funnel, compared to the china dish is hot because it is on the burner. Compared to china dish, this funnel is little bit cold. And therefore, when these vapors comes in contact with the funnel, these all the vapors, because of the cold or because of the less temperature, they will again convert it into solid camphor. And here on the surface of this funnel, they will get deposited. So here it was solid. See here, in the china dish it was solid. When we heated, it becomes vapors. When these vapors comes in contact with the cold surface of this funnel, they again converted into solid. So what is the conclusion based on this? Camphor shows sublimation. So it is showing sublimation. It was solid at the starting. When we heated, it became vapors. And these vapors, when they came in contact with the funnel, which is cold, it again converted into solid. So solid converts into vapors, vapors converts into solid. And this process is called as what? Sublimation. So with the help of this activity 1.13, we have understood what is the process called sublimation. And this sublimation process we can see with some of the substances, not with the all. All maximum majority of the substances, when you heat, they will undergo changes like solid to liquid and liquid to gases. Even when we cool, then also gases will convert into liquids. Let me put the reverse arrow. And again, if you continue cooling, then liquid will convert into solid. So this we can see in case of majority of the substances in the nature. But there are some substances which after heating, solid will directly convert into gases. Solid will directly convert into gases, and when you cool, gases will directly convert into solid. Such process is called as sublimation. Sublimation. So here, solid to liquid is called fusion or melting. Liquid to gases is called vaporization. And solid to gases or gases to solid is called sublimation. So I hope you will understand the explanation of this activity. Make note of these all the points. These all notes will help you to prepare for your test, for your exams in your school. And if you like my videos, share my videos with your friends. And if you are getting little bit also help from this all the videos, please consider subscribing my channel. Thank you so much.